x1 x2 of x1 x2. So that will just be 1 by 8 pi cube into 2 pi, which is nothing but 1 by 4 pi cube. So we can notice that fx1 x2 x1 x square is nothing but fx1 of x1 into f x2 of x2. So sorry, this is 1 by 4 pi square. So we can see that it is equal to this product. So by symmetry, so here we can say that x1 and x2 are independent, and by symmetry we can say that all these, every pair is independent. So that means x1 x2 x3 are pairwise independent. So that's the second thing. And so therefore, like, the correct options, like, we can also check the mutual independence here. So mutual independence, if we see, so for mutual independence, f x1 x2 x3 of this x1 x2 x3, this should be equal to f x1 of x1 f x2 of x2 into f x3 of x3. But we can clearly see this is 1 minus x1 sine x2 sine x3 divided by 8 pi cube. So this is not equals to 1 by 8 pi cube, so it is not mutually dependent. And similarly, independence of x1 x2 and x3, if we see, so again, like, we can quickly check x1 x2 x3. So this is not equals to fx1 x2 of x1 x2 and into fx3 of x3. So because of the coupling term sine x1 sine x2 sine x3, so that is also not possible. So therefore option C is false. Option B is true. Option A is also false. And option D also we can quickly check, because variance of xi, we know that variance of xi is nothing but 2 pi whole square by 12, since it is uniform 0 to 2 pi. So that is pi square by 3. So that means the variance of x1 plus x2, so will just be 2 pi square by 3, which is not equals to pi square. So therefore option B is the correct answer.